We're going to use some properties of logarithms that are going to help us to solve exponential equations where we don't know what the exponent is, and it's going to help us to solve equations that are not in base 10 form. So the first two rules have to do with multiplication and division. If you have a log of any base and it's a product of numbers, you can write it as an addition problem as log base b of whatever x is plus the log base b of whatever y is. This is helpful because if you know one of them, you can solve that part and then isolate the variable a little bit easier. Likewise, if you have a division problem, it's going to be subtraction. So you would say log base b of whatever x is minus the log base b of whatever y is. So let's practice a couple of these, writing it as a logarithm and as a single log. Hit pause and try them out. For 5x, it is a product, so we're going to be using addition. And we're going to write this as log 3 of 5 plus whatever the log 3 of x is. And likewise, the division problem is just going to be subtraction. So log base 3 of 5 minus whatever the log base 3 of x is. It can also ask you to write it as a single argument or a single log. So now we're going to combine it. Where we see this plus symbol and this minus symbol, we're going to remember which one is multiplication and which one is division, and we're going to combine these. Again, hit pause, try them out, and see how it goes. The answer is going to be log base 4 of whatever 3 times 5 is, and so it's the log base 4 of 15. And again, we're going to say log base 4 of 10 divided by 5, and that's just going to be log base 4 of 2. The next property is one that it helps us to solve problems that are not in a base 10 form. I find it easier than using the change of base formula even. And what's going to happen is this little exponent here is going to roll down to be in front of the log. So this becomes n log base b of x. So now practice rolling the exponent down and back up again. We're going to write this where the 3 is going to be gone, and here we want this to just say logarithm base 7 of what? Try it out. You can see what these result in. Now we're going to use all three of these properties to show how we can simplify and add some things together. Hundreds of years ago, they compiled a table of base 10 logs, and they found out what the log of 2 was, what the log of 3 was, and they had them, and just having it go up to a certain number, you can use different combinations of factors to get the answer. So we're going to use the properties of logs without actually using the log key. So if we know that the log of 2 is equal to this, and the log of 3 is 0.477, we can do these problems pretty easily. We can rewrite 6 as a combination of 2 times 3. So you would write this as log 2 times 3, and multiplication means we're going to add the two logs together. So we're going to have log base 2, not base 2, log 2 plus log 3. And since you know what log 2 and 3 are, sub them in as 0.301 and 0.477. Your result is going to be 0.778, or 778 thousandths. Now to do log of 24, you can do any combination that you want, but I think of that as 3 times 8, and 8 can be written as 2 times 2 times 2, but instead of doing this out 3 times, let's just write it as 2 cubed. So we're going to be finding the log of 3 times 2 cubed. This we can rewrite as log 3 plus, as it is multiplication, and then log 2 to the third. And if you remember that cool little exponent rule, we're going to roll this 3 down to the front. So now just sub in everything you know. Log of 3 is 0.477 plus 3 times the log of 2, which is 0.301. And you can get your answer that way. Moving on to the back page, though, we can use log base b of x to the n as a great new way to solve logs that aren't in a base 10. So let's just quickly review what this does. 10 to the 2x equals 55. Normally, we would take the log of both sides, log and log of that. The log of 10 is 1, so it would cancel that out, and we would get 2x equals the log of 55. To solve for x, we'd simply enter log 55 into our calculator and divide by 2. So the log key on your calculator is for base 10 logs only. But using these fancy new properties, we can solve this problem without graphing, without brute force. So we're going to take the log of both sides as normal. Log, log. Now this is a log base 10, but what we're going to do is we're going to roll this 6 down, this 6 to the x, roll that x down, and now we're going to write x log 6 equals the log of 55. Instead of our log canceling out, that's fine. Now we're just going to divide the log of 6 on both sides. And so x is going to equal log 55 divided by log 6. And you're fine. Now what you should get in your calculator is something close to 2.2365. And then we could round this up to 237. But here's the problem. If you didn't get this, it's perhaps because you did not close the parentheses on the log 55. When it goes into your calculator, it will look like log 55. You need to close those parentheses and then hit divided by log 6. It is not necessary to close the parentheses on the log 6. All right, now for just trying one out for yourselves. I'm going to get you started and you're going to finish this off. We're going to take the log of both sides. And you're going to have log 8 to the 3x equals the log of 21. Now we can't just cancel the log 8 because that doesn't equal anything, but remember to roll this down and we'll check back tomorrow with what you have here. And finally, using the word problems from section 3, working backwards, you can use what we've just learned about how to solve it to get a much more accurate answer. So try these out and we'll check them out in class.